Hello everyone. This is the lesson. This is a lecture video for lesson 5.2. This is PowerPoint 5.2. Verifying trigonometric identities. In this lesson, your requirement, you need to print out the identity formulas, and it's in PowerPoint number 1, slides number 6. You will need that in this lesson and on the next lesson also, the 5.3. And then also print the guidelines in PowerPoint number 2, in PowerPoint number 2, slide number 8. This is how the trig identities that you need. You need to print this out. This is slide number 6 or PowerPoint number 1 of lesson 5.1. You can find this in lesson 5.1, slide number 6. It's very important that you print this out and make this handy. And also in PowerPoint number 2, which is lesson 5.2, there is a guideline that's very, very, very important. It could help you. These are the guidelines. And let's talk about a little bit of guidelines here. Because we're trying to verify that the left side of the equation is equal to the right side of the equation. And then we're going to write whichever side we like to be equivalent to the other side. Okay. So it says right here, according to the guidelines, it says right here that number 1, work with one side of the equation at a time. If it is often better to work with a more complicated side first. So if you have the given, if you have the problem, look at the left side and the right side of the equation, because it comes with an equation. And if you look for the complicated side, meaning more numbers, longer equations, then that is, of course, complicated most of the time, but not all the time, but most of the time. So then work on that side to be equal to the other side. And then number 2, look for opportunities to factor an expression, add fraction, square a binomial, or create a monomial denominator, or something else, any mathematical concept that you think will help you prove that the left side is equal to the other side or the right side. So anything that you think will help, try it. It's okay if it didn't get to, once you try one method and it didn't help, it's okay. As long as you try, then go back again. Then number 3, look for opportunities to use the fundamental identities. As much as possible, check the problem with your fundamental identities. These are the fundamental identities. If they look familiar, then go that route. And according to some experts, like by experience, like me, by experience, sometimes there's nothing I can do but write all the trig functions into sine and cosine. Pair them up. Like sine, cosine, pair up. Secant, cosecant, pair up. Tangent, cotangent, pair up. Let's see, maybe it will work. And then, convert everything to sine and cosine. And don't forget, do something. Okay, do something. Always try something. Even making an attempt that leads to a dead end can provide insight. So don't worry if it's not correct right away. It's okay. Try again. Keep trying. every time you try, you're learning something. Alright, so that's the guideline. Okay, now we're gonna start. Here's the problem. Verify the identity. Secant squared theta minus 1 over secant squared theta equals sine squared theta. Following the guideline, of course, if you look, it's obviously the left side is more complicated than the other side, correct? Following the guidelines, right? So if you look at that, so we're gonna work on this. We're gonna work on the left side because it is more complicated. Okay, so start with the left side. Check the numerator. Secant squared theta minus 1. To me, every time it's a square, right away I'm gonna go to my Pythagorean identity. I have 3 Pythagorean identity. I think I'm gonna use the middle one because it concerns about secant squared. There is a secant squared here, and my given is in secant squared. They're not the same right now, but I can write this expression to look like this. Okay, so I'm gonna use the second Pythagorean identity. So as an aside, I'm gonna copy it here. So my aside, so I'm copy the second identity, Pythagorean identity, which is 1 plus tangent squared theta equals secant squared theta. Okay. So you see that secant squared theta, which is the same as this, is equivalent to 1 plus tangent squared theta. So that means I can substitute 1 plus tangent squared theta to secant squared theta. Okay, that's what I'm gonna do. I will substitute. So from here, 1 plus tangent squared theta. This is the value for secant squared theta. And don't forget, there is still a minus 1 right here. Don't forget that minus 1. And then of course, don't forget also that there is still a denominator of secant squared theta. Okay? So that's what I did to the numerator. I changed it. And then of course bring this down. We're trying to write this side to equivalent to sine squared. And looking at the numerator, you know that this positive 1 and this negative 1, that's a 0 pair. So I can cancel this out because that's a 0 pair. Then I have tangent squared theta as my numerator, and then secant squared theta as my denominator, and of course the right side sine squared theta. Just keep bringing this down. And right now I want that secant squared to be cosine squared because tangent is sine over cosine. So I'm gonna rewrite this expression into tangent squared theta times 1 over secant squared theta, because you can, by the nature of the given, you can rewrite this into this way, and that is sine squared theta. And now 1 over, okay, go back to your side, 1 over secant squared theta, you know that it is equal to 1 over secant is equivalent to cosine. So that means if I have 1 over secant squared, I will get cosine squared. Right? And then that means tangent squared also. You know that's tangent theta. Using our quotient identity, which is tangent u is equivalent to sine u over cosine u. So that means if I have tangent squared theta, I can rewrite this as sine squared theta over cosine squared theta. Okay. This part is now cosine squared theta. And that will be multiplied by this. Tangent squared theta over 1 is tangent squared. So I'm going to rewrite, I'm going to use this equivalent identity right here. Instead of tangent squared theta, you can just erase the denominator because it might confuse you guys. I'm going to rewrite tangent squared theta into sine squared theta over cosine squared theta. And of course, that will be equal to sine squared theta. Now, I'm going to multiply the fraction. I know that that cancels out. Sine squared theta over 1 is also the same as sine squared theta. So you see, so thus you were able to prove that or verify that secant squared theta minus 1 is over secant squared theta is equal to sine squared theta by applying fundamental identities such as Pythagorean identity, reciprocal identity, and quotient identity, and of course, multiplication of fraction. That's it for now, guys. Hope it will help, and try to study hard.